Hello everyone, and I hope this is gonna be a short one. I had an idea recently. I was really fascinated with Stirling engines and how you could use them in our, well, not daily life, but how you could use them. Because they are not really much used anymore. I think they was in the 19th century, some uses, but yeah, that was about it. So I tried to come up with ideas how to use them in the current times, and um, since the initial investment cost and the weight of the engine itself um, is a problem is a big problem compared to other engines like internal combustion engines that are well researched and all the infrastructure for producing them is already in place. So I thought, how could you use them? So in Stirling engine, if you don't know it, go to Wikipedia article. They are in principle quite simple. You have a heat gradient, like you have a hot side and you have a cold side, and the hotter and the colder each other's side are, the more energy you can pull out of it. And with a good Stirling engine, you can get up to 40% of efficiency, I think. But yeah, you definitely need a hot side and a cold side. So the hot side you can produce by burning anything. You can use any heat source. That's the nice thing about a Stirling engine. You can also use the sun. I think there was a prototype in somewhere in the USA, but that one was shut down because of corruption, I think, because the principle itself should be pretty surefire. You just need some mirrors, you need a Stirling engine, and you point the mirrors at a Stirling engine, and you're done, basically. So my idea was, how can I improve on that idea? Because a lot of solar electrical energy production has the problem that the sun doesn't shine at night and you can't store light, at least not yet, and I think we are pretty far away from storing light itself. So what we can store is heat. Heat storage is not really a problem. You can go the complicated way of storing it in molten salt, but that's quite an effort to store it. My idea was just having a big box of water that is underground and is well isolated. And as you can see here, you just use the sun as a basic water heater and pump out the cold water out of the reservoir and heat it up and feed it back into the reservoir. This doesn't need to be a cycle like is illustrated here. It can just be some circulating fluid that is heated up, and then a heat exchanger is submerged into the water and heating up the entirety of the water, because water has an extremely high heat storage capacity and it's available almost everywhere. You will see my next idea will play in the desert, but you need the water only once, because you only need it as a heat storage, not as like in powering a steam turbine or something. You could do that, but that's not the idea here. So what you do is, during the day you use the sunlight to heat your water. Simple as that. So next idea is, it's night now, and at the night you have hot water, but it's cold outside, so you have your heat gradient there. I mean, you could pressurize the water and can heat it over 100 degrees, but that increases complexity. So in a simple solution, you just have your water tank underground with, let's say, the water has a temperature of about 80-90 degrees Celsius, and you're building your plant in the desert. And I don't know if you know that, but if it's night in the desert, it is freaking cold. And I mean with cold, really cold, sometimes below 0 degrees centigrade. And that's your heat gradient. And usually you can't do anything with, hot water, but not boiling. If you have boiling water, you can power a steam engine or a steam turbine, but in this case it's just hot water. But a Stirling engine has no problem with it. You can just pump the hot water out of it, heat the hot side of the Stirling engine, and cool the cold side of the Stirling engine with the surrounding air. So it's like an air-cooled engine. And the nice thing about this is it cools the water down, but it's still a closed cycle, and it runs at night. So you can still produce stuff, electrical power at night. And if you say you want to improve on that, you could also do that during the day, because you still have the water flowing into the solar heater is cold, and the water that is flowing back is hot. So this temperature gradient could be even more, because if you are approaching the morning and you have extracted all the heat in the night to power your Stirling engine, your water might reach about 10 or almost 0 degrees centigrade. And if you start heating your water again, then the water that comes out of it here, if you calculate it directly and scale it appropriately, that the hot water can maybe be above 100 degrees. And so you have your 0 degrees water or 10 degrees water flowing in, you have your hot water coming out, and in between here, I don't know if you see my cursor, I can switch the cursor, yeah, now you see it. In between these two, there's a temperature gradient of possibly bigger than 100 degrees. If you're an engineer or you know how a Stirling engine works, you might say 100 degrees difference is really not that much, because just burning natural gas on the hot side gets you about 600 degrees of burnt exhaust that can be used to power a Stirling engine. But you need to consider that we are using water here, and water has a really high energy capacity, so you can keep the hot side of your the hot cylinder of your Stirling engine constantly at this temperature, because water is constantly flowing around that cylinder. Yeah, that's basically it. It's a really simple idea. It's just the problem is just the scaling. If you already typed the comment, I'm sorry to mention it only afterwards, but maybe you think, yeah, why isn't nobody using it? Yeah, the problem is scaling and initial cost, because you probably won't build your water reservoir above ground, because that's a really high cost, building that above ground. Building it underground means for every liter of water you want to store in your reservoir, you need to dig out at least a liter of earth or dirt or whatever your area is made of. Maybe even harder materials like solid stone or stuff. Just the basic idea is, it's really simple. It's and you can use really simple, you can use simple principles. You don't need a lot of engineering effort to make it work. It won't be as extremely efficient, but you can really simply make it work. A Stirling engine can be produced with very simple materials. Here you can look up on YouTube do-it-yourself Stirling engine, and so it can be made pretty simple, but you can also make it very complicated, where you use special alloys for the cylinders. You use pressurized helium as your working fluid and all that good stuff. But in basic principle, it's really easy. You need a mirror to heat the stuff. You need a water reservoir to store the heat, and you need a Stirling engine. And all this stuff is not expensive. You can make it really cheap. And the idea behind that was that you can produce electrical or mechanical power in the desert at night. Because during the day you could theoretically use water-cooled solar panels to produce electrical energy, but at the night you have no chance of doing anything. And using wind power in the desert, I honestly don't have any idea if there's enough wind for that. And even if there is, sand doesn't really play very nice with open mechanical parts. And I think you need a special coating for your windmill if you wanted to use it in the desert. But this is just a few mirrors. It's a water reservoir and a Stirling engine, and the rest is just plumbing. And the plumbing, everything can be made out of steel except the mirrors. They need to be made of aluminum. But the rest is all steel, and the water reservoir isolation is probably stone wool or glass wool, depending on what your budget is. And I think you can scale that down pretty easily, like having a 100-liter water reservoir and a single mirror that heats the stuff during the day, and a single Stirling engine that runs at night. Yeah, and even if this idea is never used, I hope I could entertain you a little bit. So thank you for watching, and until next time.